Hello, everyone, and welcome to our session, Five Considerations for Digital Pathology. I'm Vandana Malampati, Director of Product Management and Global Head of Product Digital Pathology. I have about 20 years of product management and product development expertise, and I have led a few multi-million dollar enterprise scale products at Dell Technologies, IBM, and also have extensive experience delivering innovative products from inception to launch at Halliburton Landmark. In my current role at Iron Mountain, I have led the team to incubate the new digital pathology solution that is currently being focused on launching it globally. I was a master inventor at IBM and a AWS certified cloud practitioner and also a certified API product manager. Today, along with me, my coworker Klaus Walters, who is the global head of Iron Cloud Services for Iron Mountain, will be talking to us about Iron Cloud. Klaus brings over 30 years of business experience working at Fortune 500 companies as well as startups. Klaus has spent the last 25 years in information technology industry serving in many leadership positions including operations, sales, M&A, and strategy. In his current role at Iron Mountain, Klaus is focused on assisting customers with their digital transformation objectives by providing solutions to both protect and unlock value from their digital assets. Today, for this webinar, we will be focusing on storage challenges. The first is around inefficiency. When you are dealing with glass slides, it can be difficult to put your hands on the actual glass slide that you need. This might be because the slides were previously retrieved and the accession may have been separated slightly. Perhaps it was moved and it's on site somewhere, but the customer is not sure exactly where it is. All these examples drive inefficiency when dealing with physical glass slides. Sharing can also be a problem when you or I have to put the physical glass slide under a microscope to be able to see it. If we need to send the slide to someone else or have them come to us, we would have to get on a conference call or share the glass slides under a electronic microscope. The constraint here is somebody has to handle the physical slide in order for the collaboration to happen. Collaboration can only happen when the physical glass slide is present. The third aspect is storage challenges can be considerable problem for customers as they try to adopt digital pathology because the image size is so significant for pathology images as compared to almost any other imaging that happens in a hospital. Pathology slides can be anywhere from 1 gig to a gigabyte and a half for a 20 magnification slide. And that would be on a smaller slide. But if you are doing clinical, this could be anywhere from 3 gigs to, I have heard some doctors say there are 9 gig slides. But when you're looking at, and also when you're looking at 20 to 25 slides per accession, this can easily grow to be over 100 gig of storage per accession. The ability to store and manage that storage volume is significant for our hospitals and academics. All of this inefficiencies leads to overburdened staff. We saw in pathology trend slide that the pathology space is quickly approaching a 10% growth rate. This means that staff are being asked to do more with less. It's a industry-wide challenge. And the next drawback is the potential for loss. Anytime our customer has to transact something physically, there is a risk of slide loss and damage due to breakage as we handle and move these slides around. Iron Mountain's digital pathology on demand service has three key ways to speed pathology collaboration. The first is to get what you need when you need it. We are not suggesting to image everything. We are suggesting getting just the slide images information just when you need it. So this eliminates the physical movement of material and scan the accession as you identify the need to see it. And let's get these slides available for pathologists to read, share, annotate, and collaborate to drive the efficiency. Sharing and collaboration is the second pillar. By eliminating the physical movement of slides, we can now view, annotate, and compare without having the slides physically underneath the glass microscope. And finally, we can use a secure and scalable solution to manage the growing digital inventory. Iron Mountain has made significant investments in digital pathology, and we are definitely industry experts in protecting the assets. Storage challenges can be considerable problem for customers as they try to adopt digital pathology because the image size is so significant for pathology images when you compare to other imaging that happens regularly in a hospital or a research facility. Pathology images, as I mentioned earlier, can be anywhere between a gigabyte to around 9 gigabytes based on the magnification. So when you look at the number of slides or when you're looking at significant number of slides per accession, this storage, digital storage requirement can easily grow to 100 gig of storage per accession. The ability to store and manage that storage volume is significant in the hospitals and academics. So when you are contemplating digital pathology storage, there are 5 storage considerations you need to think about. We are going to look at what questions or what do you need to think about when you are asking about or validating the external storage options and why these questions are important. So we will also discuss in this webinar why outsourcing your digital pathology image storage, which IRM is leading with its DPOD or digital pathology on demand offering. Lastly, what can the organization do to generate more value from the data you own? So scan and store yourself, scan yourself and store on cloud, leverage third-party scan and store service, archive with confidence, unlock value from your data. Let's look at each one of these options. Option 1, scan and store yourself. For small scale operations with limited scanning needs, scanning and storing on-prem is feasible. The organization may require a single scanner to process a moderate number of slides. For example, 50 slides per day would generate about 80 gig of data per day. The PC for the scanner could potentially store 22 terabytes, enough to hold a year's worth of data. The drive could be swapped out each year to keep the operation running. In this scenario, there could be difficulties with image management, such as security vulnerabilities related to protect health information and limited scalability. The organization would also need to consider how to handle redundant and offsite file storage requirements. This particular approach involves staffing of the resources, capital costs, on site IT expertise, and due to these challenges, there are better options for moderate to large scale operations and those that need to quickly establish a cost effective digital pathology practice. Now, when you look at the risks are higher as the data storage is not redundant, secure, or in the cloud. Accessing the data may interfere with concurrent scanning operations. Dismounted drives are not accessible and can pose security vulnerabilities if not properly encrypted and managed. The solution is not readily scalable if the scanning volume increases. Data security and protection of personal health information may not be assured. The scanning equipment consumes valuable local floor space and human resources. Any organization would need expert help in addressing each of these problems. As the digital pathology systems complexity increases, so do the capital expenses, the amount of IT expert time required to design, test, implement, and maintain the solution. And also, there will be difficulties when the operation required needs scaling up, even if it is moderately scaling up. Option two, that is the hybrid model. It seems simple enough to scan files locally and store them in the cloud. Many organizations are, in fact, doing this for medical image storage and using the cloud for medical image storage. This hybrid solution resolves many problems with an on prem model, including the need for more redundant offsite storage. While the cost of storage continues to decrease, the volume of data to be stored impacts the choice of storage methods and locations. For large data sets, it is necessary to balance the cost of storage with the time of access and cost of regenerating the data. Cloud storage providers typically have various data redundancy techniques. Accessing the data from the cloud will not likely interfere with concurrent local scanning operations. Cloud storage is essentially limitless, but it's not free. The organization cost will need to be modeled and understood to ensure scalability and also take into account the egress and the ingress fees associated by frequent access of the data that is stored in the cloud. The hybrid approach places high demands on local IT and network resources and also requires secure data connections. There are many security concerns related to public cloud storage of patient information, including data loss and unauthorized access. There could also be, like I mentioned previously, the egress fees posed by the cloud providers and also the pricing structure associated with moving data among the different storage tiers is not simple. Let's look at the option three, service provider cloud storage and third party scan and storage. The primary concern of any healthcare organization is the well being of patients, which means many are opting to outsource the entire digital pathology image storage process. That means a trusted professional will ensure redundant, secure, cloud storage and be responsible for efficiently scanning slides and managing data access. The concept is simple. The cloud storage service provider collects the pathology slides, moves them to a secure temperature controlled offsite storage facility. The provider will access and scan specific slide sets at the organization's request, minimizing transport and maximizing security. The slides are returned to storage after scanning. The provider safeguards the image data at one of its secure data centers, offering cost effective storage at a reliable rate, delivering all the security and data privacy requirements. The healthcare professionals can return their focus now to their core business function and not worry about the different hassles associated with digital pathology adoption. Let's look at how Iron Mountain uses Iron Cloud for digital storage. The concept is very simple. We collect the data, scan the data, and the scanned images are in the Iron Cloud, which enables anytime, anywhere access of the data. And inherently, the Iron Cloud protects the data. I will let Klaus, my coworker, talk a little bit more about how Iron Cloud is used in digital pathology.
All right, thank you, Vandana. Now I'd like to discuss Iron Cloud. Iron Cloud is where we store the images, as well as the value proposition would be to you. Iron Cloud is Iron Mountain's operated cloud. It's our own private cloud-based service, which is delivered from Iron Mountain owned and operated data centers. It allows us to provide you with a tiered storage model that keeps your images in the hot tier for immediate access, a warm tier after 30 days of living in the cloud, and then an archival storage tier where they can exist for many, many years. The platform offers inbuilt durability, ensuring your data is available now and in the future. As the data volumes grow, it continues to be stored safely, and we're going to help you drive down your total cost of ownership by being a lower cost model than the hyperscalers who may keep everything in hot storage. This gives you unlimited data access without adding additional egress and ingress costs. Finally, this is done using a highly secure network using the zero trust model. And in some cases, we're actually creating an air gap between the data and the storage of the data. So it has high security features built into the product. How does Iron Cloud work? Data is moved to Iron Cloud using the industry standard S3 protocol. Initially, the data lands in cache on the cloud gateway, and it's then copied to the active tier. The active tier allows for instant access for the first 30 days in Iron Cloud. Over time, as data meets the predefined lifecycle management settings, it's then moved to tape for long-term archiving. Initially, we store it on the warm tier for quick availability, and then finally, it moves to the cold tier where it's maintained for long-term archival purposes. The Iron Cloud digital pathology storage solution from Iron Mountain combines multi-tiered storage options with an on-demand pricing model that includes online access, data protection, and archiving in one easy-to-consume model. The active or hot tier data is fully online and available for immediate access. It's held in the system for a set number of days that's determined by your organization. The warm tier is where data is migrated from the active or hot tier and then stored for a length of time determined by your organization, but it's less likely to be needed immediately, and warm data is generally accessible within 3 to 5 minutes. Finally, cold tier data is where active or hot tier or warm tier has aged out after a number of days that are set by your organization. This data is offline and protected by an air gap, can be stored for up to 10 years at a greatly reduced cost, and is normally accessible within 24 hours. Healthcare organizations can work with Iron Mountain to configure timelines and criteria for each storage tier to suit their own purposes. Pathologists and others with access can request and retrieve data immediately from the active hot tier, which uses the industry standard S3 protocol. Our digital pathology tool uses the Iron Cloud storage tiers. There are 4 layers of storage tiers. We're talking about 3 primary storage tiers and then the restoration tier. The first is the active tier when the data is fully online. It is in the high availability model, keeping the digital images for about 30 days after it's created. During the 30 days is when it's most likely to be viewed and accessed, and when information needs to be shared and collaboration happens. From the active tier, it moves to a warm tier. The time period is approximately 31 to 91 days. The images are still available, but it might take a minute or 2 for the images to be restored back to the active tier. We call this the warm tier. It's not fully archived yet, but it's not in a high availability mode. It's still accessible within a few minutes. As it ages out of the 90-day tier, it moves to a cold tier or archive and then becomes truly offline. It's protected by what we call an air gap. It won't be accessible from the internet. It's required that the digital images get restored, which can take up to 24 hours to happen. When it does become available, it moves back to the active tier for consumption. These timelines are configurable based on your requirements. So when we said 30, 90, and then cold for up to 10 years, these are standard values we offer. The length of time may be adjusted based on your specific preference. If you believe that you want your active tier for 60 days and warm tier for 1 year, we can change those based on your configuration settings. Finally, for restoration, this is where you identify what images you need brought back online. If the images are in the cold tier, the user will select it and the slides are brought back online seamlessly for you to view. Thank you, Vandana. I'll pass it back to you now.
You have heard from Klaus about Iron Cloud and the benefits of storing the digital pathology images in Iron Cloud. So let's look at why we are helping the clients with digitizing the pathology slides. Digitizing slides is a significant leap forward in generating value by giving the ability to allow the information to be passed between multiple pathologists, multiple users who see these images. Having digitized images gives the ability to drive marketplaces where the images can be collected, anonymized, and maybe marketed for sale. It plays a significant role when you look at how research can use these digitized images, or and also how one can use these digitized images for training and education purpose. For example, in the case of research, a cohort of images with components of metadata attached can be sold to AI companies as they train their AI models on different algorithms, or as customers wish to engage with AI companies to run algorithms on their own slides. So there are many different advantages of digitizing these glass slides, pathology glass slides. How would you pick a right partner in your digital pathology journey? Iron Mountain is a global business who is dedicated to storing, protecting, and managing information and assets. Organizations across the globe trust Iron Mountain to store and protect information and assets. Thousands of local enterprises work with Iron Mountain or our Iron Mountain customer. In fact, over 2,000 healthcare customers and top 10 global pharmaceutical companies trust Iron Mountain to store and manage their most valuable assets. There are about 68 exabytes of data under management with over 850 million patient records and over 1 billion medical images and 1 billion pathology slides stored within Iron Mountain facilities. Iron Mountain's 1,450 facilities around the world serve more than 230,000 customers in 63 different countries. Our 94 imaging centers digitize more than 1.5 billion documents every year. We have extensive experience with healthcare and research companies, and this has enabled us to develop a proven process for helping pathology customers. And our data centers are powered by 100% renewable energy with 350 megawatts plus data center capacity. For pathology slides, to critical business information, works of fine art, to original recordings of treasured artists, our customers can definitely rely on us to protect what they value and help unlock its potential. Iron Mountain truly does offer a end-to-end solution for pathology where you can physically store the blocks and the slides associated with your pathology department. You scan these slides within Iron Mountain's facilities. That is where the scanners are hosted. The customers can store the scanned images in Iron Cloud and view it in an integrated viewer. So the chain of custody is not lost. To learn more about Iron Mountain's digital pathology on demand offering, please contact your sales rep to show you a demo of how it is done. And we can show you how the end to end chain of custody works in this particular solution. Thank you.